Hi, everybody. This is your week 3. Okay, percentages 2. So you're going to do more on interest and investments. Okay, so in the last week, you have seen how to work with percentages, and you have seen what are simple interest, what are compound interest. And this week, we will start with generating a formula for simple interest and compound interest. And then we will look into the following terms, which you will come across very often when you make an investment and when you want to make decisions such as to accept or reject a project. That is, basically, you want to make a better decision to take a project for your company that promises you better return than you invested. Okay. So let's start with simple interest and compound interest. Okay. So what is interest? So when you look for this word interest in dictionary, it's very funny, isn't it? You come across these definitions, yeah? But what we are talking about is not the interest you have. We are talking about this interest, isn't it? So it is a money paid regularly at a particular rate for the use of money lent or for delaying the repayment of a debt. Okay, that's the interest we are talking about, and that's where what we did in week 2, isn't it? Okay, so let's start with a simple example for simple interest and compound interest. Then we'll generate a formula. Yeah, I'm sure you've done that in school days. Yeah, but I just want to go through it before we do further topics on investment, because it's very important that you're good at compound interest to understand that. Yeah. Okay, Glenn invested 750 pounds for 4 years at 7.5% per annum. Look at that. I'm using PA. It is a short form for per annum, per year. Okay, so Glenn withdraws the interest. So he is withdrawing the interest each year. He is withdrawing the interest each year. How much is the investment worth at the end of the period? Okay, so he is withdrawing each year. So this clearly shows that we are interested in simple interest, isn't it? We are not calculating on the investment in the next year. Yeah, it's always on the principal amount. Okay, so why don't you pause the video and do this problem by yourself first? Okay, try this out, guys. So how much is the investment worth at the end of 4 years? That's the question. Okay, good. So what you did was, the interest rate is 7.5%. So in decimals, it is 0.075. And the amount of interest paid each year will be the principal amount times the interest rate. Yes. And you get £56.25. And then the amount of interest paid over 4 years will be this amount, the amount of interest paid each year times the principal amount times the number of years, isn't it? So and you get £225. That is the amount of interest you pay after 4 years. So what will be the investment at the end of the 4 years? It's going to be 750 plus this interest amount, isn't it? 225, which is 975. So this investment after 4 years is worth £975. Do you get it? Yeah, good. So now let's generate the formula for this. Let's take the notation for the original investment or the principal amount or the loan. It could be an investment or could be a loan. Yeah, you could either give the bank the money or take money from the bank. It could be either way. Yeah, so that's the principal amount P. I is the amount of interest. R is the interest rate expressed as a decimal. Please be careful. This should be in decimal. Okay. T is the number of times the interest is added. So the formula is I is equal to PRT. You have used it in school, isn't it? It always makes it easy when you have a formula, isn't it? I is equal to PRT. That's your formula for simple interest, isn't it? So now let's do some compound interest problem, okay? Let's go to the same question, but I have changed the question a little bit now. Glenn invested 750 pounds for 4 years at 7.5% per annum. Glenn reinvests. He reinvests the interest each year. Okay, he's reinvesting the interest each year now. So how much is the investment worth at the end of the period? So how much is the investment worth at the end of 4 years? So let us now consider the situation when Glenn does not withdraw the interest at the end of the year. Okay, this is the case now. Okay, it's not the case like before. Yeah. So here, what are you doing? He does not withdraw the amount. So amount of interest in year 1 is the principal amount times the interest rate. Yeah. So that 0.75, and you get 56 pound 25 pence. And the amount of money at the end of year 1 and invested in year 2, that should have both the interest along with the principal amount. So look at that, because he reinvests the interest. So 750 plus 56.25. So you get 806 pounds 25 pence. Now again, you have to find the interest on this amount at the end of the second year. So you get 60.47. Now again, you have to find the amount of money at the end of year 2. For that, you have to add the interest on it. So you get 806 plus the interest. There you go. And so on. You calculate, yeah, each year. Okay. So that's how you calculate. So you can do this in a different way. You can also use the multiplying factor. Yeah, some of you would have already used that now. We can calculate the amount using the multiplying factor. So look at that. That is increasing. It's a compound interest, so it's increasing. So you're going to add 100 plus 75%, 7.5%. So in decimals, it's going to be 1.075. That's your multiplying factor. Okay. So now amount of money at the end of year 1 and invested in year 2 will be the principal amount times the multiplying factor. Similarly, for the next year at the end of year 2, yeah, and which is going to be invested in year 3, yeah, that will be this amount times the multiplying factor, and so on. Okay, so that's how you calculate compound interest. Yeah. Okay, what about this question? Why don't you try this? Pause the video and try this, please. Good. Find the value of a 3,000 pound ISA savings bond. That is, remember, we spoke about it in the lecture too. It's an individual saving account. Okay, you can look into the Wikipedia for more about it. After 4 years, if it gains interest of 6% per each year, so it's gaining interest. Look at the word gain. So it's increasing. Yeah. So the multiplying factor for each year will be 100% plus 6%. In decimals, it is 1.06. So after 1 year, the value is going to be the amount times the multiplying factor. Okay. Then after 2 years, this amount, don't go to that amount, please. This amount times 1.06. So you have 1.06 square. Then after 3 years, the value will be this amount times 1.06. It's, look at this pattern, beautiful pattern, as we saw in the last week too. We are getting a new, nice, beautiful pattern here. Yeah. After 4 years, you can simply say it is to the power of 4, the multiplying factor to the power of 4. That's a beautiful pattern here, isn't it? So the multiplying factor is what's happening to it. It's being raised to the power of the number of times that the increase or decrease is taking place, isn't it? In this case, it is an increase. So the multiplying factor is raised to the power of the number of times that the increase is taking place. Yeah. So that's the beauty of compound interest, isn't it? Okay. And now let's try to generate a general formula for compound interest. Yeah, in Max, you would like to have a general formula for everything. That makes our life easy. Yeah. Okay, let's go for the notation first. Let's say that Pn is the amount after n years. What does that mean? Means if I put n is equal to 0, P0 is after 0 years, the principal amount after 0 years, which is nothing but the current, the now, the today's price, yeah, at the start. P1 is after 1 year, that is after 12 months. P2 is after 2 years, and so on. Pn is after n years. Okay. Now, R is the interest rate expressed as a decimal. Okay, R, I'm going to take it as the interest rate. Okay, and it is in decimals. So the interest rate is 12%. That means R is 0.12. If the interest rate is 60%, then it is 0.06. Yeah, and the general formula is Pn is equal to, that is the principal amount after n years is equal to the principal amount, the current amount at the start, 0 years, times 1 plus the interest rate to the power of number of years. So that's your compound interest formula. Always good to have a formula, makes our life easy. Yeah, cool. So that's your compound interest formula. Okay. Why don't you try this problem? Okay, good. How much must I invest at 5% per annum compound interest if I am to have 10,000 after 5 years? Okay. So please use this formula. You know what is given in the question. N is given. The number of years is 5. The rate is given 5% per annum. The interest rate is given. And the amount after 5 years is given, 10,000 pounds. So you can, there are 4 variables. 1, 2, 3, 4. Of these 3 variables are given. So easily you can find the 4th one. So please give it a try. Good. So that's how you have, isn't it? You get, and then you get the principal amount to be 10,000 by 1.05 to the power of 5, which is nothing but 7,835 pounds, 26 pence. And I write it beautifully. Hence, I need to invest 7,835 pounds to have 10,000 pounds after 5 years. Look at that, guys. I have rounded it, okay? If the question, in the exam, it will be clearly mentioned whether you have to round it or not, okay? So here 2 is less than 5. So I have kept this number 5 as 5. If this number 2 was, this number 2 was 5, then I would have rounded it up and said it is 7,836. 5 and above, I will round it up. 5 below 5, always round it down. Okay. Okay, let me erase this so that it doesn't stay there. Okay. Okay, so that's your compound interest formula. Okay. So this formula or similar formula can be used in many situations where an amount changes at regular interval by a fixed percentage. Okay. So this is the increase and that's the decrease. Okay. Okay. Now let's go for investments. Very interesting topic, isn't it? I know most of you are eagerly waiting to listen to this. Yeah. What is an investment? It's an investment. What is it? It's a cash flow and in and out. Yeah. So investment has cash flowing out, probably when you're investing some money, or cash flowing in, probably when you're making some profit, isn't it? Just an example. Yeah. So it could be flowing out and flowing in. Yeah. Okay. So to understand this first, the most important thing, yeah, that is the time value of money. That's the most important thing. Let's understand what is time value of money before we get into other ones. Yeah. Time clock. Yes, it makes a lot of sense there, isn't it? Time value of money. Yeah. Let's what is this? How money grows with time. Yeah. How much money is not just that matters. What matters is when you get the money or when you give the money. Yeah, that matters. Okay, that also matters. Okay, that does matter. It's not just the amount of money you're getting is is important. What is important is also that when you get it in 1 year, 2 year, and yeah, when you give it also, maybe sometimes it's giving, yeah, maybe you're taking a loan. Okay, so it's very important that the time value of money is very important. Yeah. Okay, let's consider that you put £100 in a bank and the bank promises you to give 2% interest. Okay. And then an insurance company comes around and says that, okay, I'll give you £100 now, £101 in a year, and then in 2 years, I'll give you £103. Okay. At a glance, you will obviously say, okay, I will go for this larger amount because 103 is obviously bigger than £100. Yes. So you will try to choose this. But then you will be thinking like, this is only after 2 years. After 2 years, I get £103. Yes. Is there something I'm missing? Yes. Actually, yes. You will be missing out the 2%. The 2%, yeah, interest. After 1 year, the bank will give you how much? 100 plus 2, which is equal to £102. This is obviously bigger than this, yeah, in this situation, okay? And it's a better amount, yeah? What about after 2 years? You calculate again the same way, and then you get 104.04 in 2 years. Again, you see, putting the money in the bank at 2% interest is a better option than this insurance company is promising you to give after 2 years, okay? So it's just an example, okay? It need not be, a bank need not give you the right, interest, or the better option all the time. But I'm just taking an example to help you understand the time value of money, okay? So look at that, how beautifully you can see that the bank is doing better here, yeah? So this concept that not just how much money you get matters, but also when you get it also matters. And this is called time value of money, okay? Another way to understand this concept of time value of money is to understand the concept in terms of present value. Okay, that's a beautiful way to understand the time value of money. Let's go back to the same example now. Okay, look at that. You have the pound 100 in the bank at 2% interest. Okay, after 2 years, you have 104.04, 104 pounds and 4 pence. Okay. If you want to know what is the present value, that is the value today. So let's see what is present value first, okay? So the value today, now, for this amount, what will you do? What will you do? If you want to know the present value, you know the value after 2 years, you want to know the present value, what will you do? Today's value. Today's value is this, okay? To get the today's value. Now, this is after 2 years. You want to get the value for before 2 years. What will you do? You will work your way backwards. This is why I was stressing so much in the week 2 to work backwards. Yeah, now you need to work backwards to find the present value. Yeah, so the present value is 100 pounds. What did you do? You divided this new value with the multiplication factor to the power of 2 because it's 2 years. Yeah, and then you get the present value, 100 pounds. That means the present value is 100 pounds, and this is the amount you should deposit to get 104 pounds, 4 pence in 2 years. Okay. Okay. So why is this present value so important? You already know the answer now, yeah? Simply because the money now is more valuable than the money later, isn't it? Because you can now invest this money on something else, yeah, and make some profit also, maybe, yeah. So now let's see what is the discount rate. Okay, what is discount rate? Okay, we'll stick on to the same example. Okay, Going back to the same example where the insurance company has promised to give us 103 pounds in 2 years, okay? How do we decide which is a better option? Is the bank giving us a better option or the insurance company giving us a better option? We know now that bank is giving 2% interest and the insurance company will pay after 2 years 103 pounds. Okay, how am I going to decide this? Yeah, so we calculate the present value. How do we decide that? We calculate the present value. Okay, and then compare the two. So what is the present value here? This is today's value because you are depositing 100 pounds in the bank. So that is your present value, today's value. But in this case, you have to work your way backwards to find the present value. Okay. So that is your present value, 99 pounds. So you divide 103 by 1.02 to the power of 2. And this is your discount rate of 2%. Okay, that's your discount rate, isn't it? So what we are doing here is we discounted the 103 pounds, yeah, 103 pounds by a discount rate of 2%, isn't it? And we see that the present value is 99 pounds, which is less than the 100 pounds which the bank is giving. Yeah, the bank's present value that's here is 100 pounds. So which is the better option? Naturally, this is your better option. So look at that. That is the importance of present value, time value of money. Yeah. So you try to compare the present value and then take a decision which one is a better option. Okay. Now let's see what happens if I decrease this discount rate. Okay. What happens if I decrease this discount rate? If I bring this down. Yeah. Okay. I'm going to bring that discount rate to 1%. Okay. Look at that. The present value here again remains the same, pound 100, yeah, 100 pounds. What happens here? The present value changes, isn't it? Because I have decreased the discounted rate from 2% to 1%. So my present value now will be at the discount rate of 1% will be 100 pounds and 97 pence. Now, which option is better? Which option is better? This is a better option, isn't it? So the lower the discount rate, the higher the present value, isn't it? So that is the story of discount rate, present value, and the time value of money. Okay. Okay. So how much must I invest? Let's go back to the previous example. Yeah. How much must I invest at 5% per annum compound interest if I am to have 10,000 pounds after 5 years? Okay. In effect, we calculated how much 10,000 pounds in 5 years' time is worth now. That's what we calculated, isn't it? The question now becomes, because now that you're doing discounting the discounted rates, it becomes how much would 10,000 pounds in 5 years' time be worth now if the discount rate is 5% per annum? Look at the beautiful way of understanding the question, yeah? So that's how it changes, isn't it? So this is your future value now, and this is your present value, okay? So you work your way backwards to find the value for now, for today, the present value, okay? And this whole process is called discounting, isn't it? So present value, let us now redefine this term in the formula, okay? The compound interest formula, okay? I'm going to redefine this because now that we want a formula for present value, okay? Okay, Pn is the future value and P0 is the present value, the start value, the beginning now, the value now. And R is the discount rate because we are going backwards to find the present value, the starting value, today's value, okay? So rearranging the formula, we get the present value is equal to the new value, the future value divided by 1 plus the discount rate. Look at that, R is the discount rate now to the power of N, the number of years. Okay. Okay. So that is a very important formula, guys. Yeah, that's how you calculate present value. Present value is very important to understand and compare which investment is better for you. Okay. Now use that formula and calculate the uh, calculate for these two different discounted rate. Okay, calculate for 4 years. Okay, what will be the present value? Okay, calculate the present value. So you have this principal amount given, number of years given, the discount rate is given. Now find the present value using this formula. Okay, good, very good. You all have tried, yeah. So you get for the first at 10%, it's going to be the multiplying factor is 1.10, isn't it? So 1.10 to the power of 4 years, you get 20,490. And for 2%, you get 1.02 to the power of 4, isn't it? Look at that. As the discount rate is decreasing, you can see that clearly as the discount rate is decreasing, because it's in the denominator. Look at that. It's in the denominator. Because the denominator value is decreasing, what will happen to this value? When the denominator is decreasing, obviously this will increase. That's what is happening. So what do you understand from there? The lower the discount rate, the higher the present value is. Yeah, that's very important. Okay, guys, you should understand that. Yeah. So when you lower the discount rate, the present value increases. Okay, now let's see what is the net present value. Okay, so if I ask you a question, what would you rather have? Would you rather have £1,000 now or £1,000 in a year's time? Which option will you choose? I'm sure you would have chosen now, because obviously if you have the money now, you can use that money, invest it, and do something with it. You could earn a return on that money. Whereas getting £1,000 in a year's time, you will have an uncertainty in it, whether it will rise or not. This is why we have the net present value. Yeah, that's importance of understanding the net present value. Okay, that's why we have net present value. That is, it gives us a value of a project in terms of its cash outflow and cash inflow. Okay, so the understanding of net present value is very important. A positive net present value for a project will suggest that the investment project should go ahead, and a negative value would suggest that the project should be rejected. You should not take the project because the return is going to be lower from this project. That is, the net present value will give you a better idea of the cash flow and will allow you to gauge the monetary value now rather than future. So you will know the current value, the present value, the today's value. Okay. So to understand this, let us take a case study. Okay. Okay. So ABC Holdings are a small company that specializes in developing small out-of-town shopping centers. It is currently investigating 3 possible projects located at A, Andover, B, Bristol, and C, Carlisle. Okay, at these 3 places. Okay. My mouse. Yeah. The sites at Andover and Bristol both require an investment of 4 million pounds, but Carlisle requires an investment of 5 million pounds. Okay, that's the question. Okay. Income from the rent is guaranteed for 5 years before the shopping center is transferred to the local council. Okay. So you have to now decide which is the best investment. Okay. So let's analyze each of this project now. The Andos and the, I will say A, okay, A, B, and C. Okay. Look at that. This A, the project A here, what's happening? Look at the cash flow here. Is it very evenly set? Yeah. So A has an even cash flow. Yeah, has an even cash flow, while the other two has an uneven cash flow, isn't it? Yeah. With A, since the cash flow is even, the investment is expected to bring income that is constant every year. Yeah. So how about uh, uh, calculating the payback period? Yeah. So let's see what is payback period first. Okay. How many years before investment is recovered? What is that? Yeah. For example, let's see what is it. Okay. Before that, let me show you the profit that we have here. Okay. In each case, here, how much profit have we made? The cash outflow. One more thing, the cash outflow is negative. Can you see? The cash outflow is given in negative because this is the amount you're investing first. Yeah, it is negative. And all these are cash inflow because this is, so you represent it as positive. So what is the profit you make here? You have -4 plus 5, which is 1. Here you have -4 plus 1.5 plus 2.5 plus 0.5 plus 0.5, which gives you 1. And here you have -5 plus 0 plus 0.5 plus 1.5 plus 2 plus 3, which gives you 2. It looks like this is a better investment, isn't it? Okay, let's first see what is payback period. And what is payback period? It is the time required to recover or pay back the original amount of investment. That is how many years it takes or how much time does it take before the investment is recovered. Okay. And the formula which we use to calculate the payback period is original investment over the cash inflows per period. Okay, it's for every period. So per period, you calculate for each and every period into 100%. Okay. So the payback period, you can see that the payback period is longer than the, so if this is payback period is longer than the project, is usually associated with high risk. So usually if it is longer, we usually drop it. Yeah, you reject the project. Yeah. So this is what you have to understand here. The main drawback of this payback period is, as you can see, it doesn't take into account the time value of money. Yeah. Payback period is usually used when a company only has a limited amount of funds. They might be able to only undertake one project at a time. Probably they don't have fund, probably. Yeah. Therefore, their whole focus, the management focuses only on recovering their initial investment. And the main advantage of using payback period is its simplicity. The formula is so simple. It is easy to calculate. Yeah. It is easy to calculate payback period once you know how the cash flows. Yeah. So it is a nice, easy way to calculate, but it does not take into account the time value of money. Okay. So that is one major drawback for payback period. Okay. So I have calculated the profit here. Yeah. So what can I say? The Carlyle looks like the best investment looking at that. Yeah. And we have not taken the present value into consideration, isn't it? Now let's look at their income. Okay, so what is the income, each of them? What have they got here? Yeah, so A, it's 5 million pounds, and B is 5 million pounds, and C is 7 million pounds. Yeah, just add up. Yeah, 7 million pounds. And the average income per year will turn out to be 1, isn't it? And 1.4. Yeah, so 5 is the income, average income per year. Per year, 5 divided by 5 is 1. 5 divided by 5 is 1. 7 divided by 5 is 1.4. That is your average income per year. Now let's understand what is accounting rate of return. Yeah, to understand this, it is a average income per year. What is it as a percentage of the investment? Yeah, it is actually calculated using this formula. Okay, average income per initial capital into 100%. Yeah, it is usually expressed as percentages. Yeah, so let's calculate this using the formula. Okay, my mouse is having a trouble. Yeah. Okay. Okay, so I have average income here, and then I divide that by my initial capital amount. How much did I invest first on this A site, on this project? 4 million pounds. So that is my capital amount, isn't it? So 1 divided by 4 times 100%. Similarly, yeah, similarly, I can calculate for B, then I can calculate for C. And now I can compare what is the best one, which is the best option here, which is the best investment here. It clearly shows that Carlyle is the best investment, isn't it? Now it's a C. Yeah, Carlyle seems to be the best investment. Yeah, so that's how you calculate ARR and then compare it. Okay. So now the important thing again here is both the methods, what we use, the profit and the ARR, they did not take into account the time value of money. Yeah, what should we do then to take into account of the time value of money? Yeah, present value of money, that's right. Yes, so that's the importance of present value of money, isn't it? So in other words, money in the future is not worth as much as money now. Yeah, so we need a way of calculating how much money in the future would be worth now, today. This is known as discounting. We saw that already. Yeah, what is discounting? You work backwards and find the amount of money that is worth now. Yeah, so look at that beautiful cash flow. Now let's go back, and so this is worth more than the money now, the future. Yeah, this is worth more than this. Okay, so we can now use present values to help us decide which is the best project to invest. Okay, now we are going to give importance to the time value of money. That's the beauty here, isn't it? When you give importance to the time value of money, and then you are doing probably you're taking the right decision probably. Yeah, so let's do that. So I'm going to calculate the present value with a discount rate of 8%. Okay, the first one I have calculated here. So I'm going to calculate the present value at the discount rate of 8%. So do you all remember the formula for present value? Yes, I'm sure you know that. Yeah, so I'm going to calculate the present value. Now today's value is this value, that is 1 million divided by, what is my discount rate? 8%. So it's going to be 1.08 because it is just after 1 year, so to the power of 1, and I get that. Okay, now I want you to pause this video and calculate the present value for each of them. Yeah, for each cash inflow. Look at that. Careful, guys. This is negative because it's the outflow. That is an initial capital amount which you have invested. Okay, that is a cash outflow, and these are all cash inflow, cash inflow, cash inflow. Okay, so now for each cash inflow, I want you to calculate the present value, single cash inflow. Okay, one by one. It's very important you calculate single. Okay. Okay, so that's what you got for the project A. And for project B, and for project C. Okay, please make use of the calculator and calculate. Please don't just leave it, because this is the way you will get into the habit of making mistakes and then learning from it. Okay, so, and then you can find the total amount by adding each of them, the total cash inflow, the cash flow in, yeah, and then you calculate the net present value. So the net present value is the cash outflow, that is how much you have invested, minus how much you have regained, how much you have earned, how much return have you got, the total cash inflow, yeah, the total cash, just, yeah. So you subtract these two and you get, it's negative. Can you see that? For this, it's positive. For this, it's positive, yeah. So which is the best option now? Pause the video for a minute and think, which is the best option? Which is the best investment you have made? Yeah, that's right. That's B. All this time we thought it's Carla, which is making profit, yeah, or which is doing best, yeah. Now when you are looking into the present value, you have decided that B is the best investment. So Bristol now seems to be the best investment. Okay, now let's see the last topic, internal rate of return. Okay, what is it? It's the value of the discount rate that makes the net present value equal to 0. The idea is that you never want to take a project, yeah, take on a project for your company that returns less money than you invest. Okay, you don't want to do that, yeah. So look at that. That is the internal rate of return. That is the value of at which the discount rate. See, that is the value at which, this is the discount rate at which the NPV is 0. So that's the value where NPV is 0. Okay. So you do not, let's go back to the same example. You do not want to take on a project for your company that returns less money than you have invested. Yeah, you don't want to do that. Okay, so that's why you have this concept of internal rate of return. Okay, so look at that. That is negative, that is positive. Negative somewhere here and positive somewhere there. Yeah, so somewhere in between it is 0. Yeah, somewhere in between the NPV is 0. There must be a value of the discount rate that makes NPV equal to 0. And that is your internal rate of return. You don't have to calculate that in this module for now. So for this test, for the mini test one, you don't have to calculate it, but you just have to understand the basic theory behind it, yeah? That internal rate of return is a discount rate where the net present value is 0. Okay, so that's the end of your lecture for week 3. Okay, so we have seen a formula for simple interest and compound interest. You have seen the importance of time value of money. You understood the time value of money in terms of the present value and the discount rate. And you have seen that when you have cash outflow and inflow, how to calculate the net present value and how important it is, because it takes into account the time value of money, isn't it? We said that payback period method of calculating was not good because it doesn't take a time value of money, although it is it's the most simple method to use, isn't it? To make a decision whether investment is better or not. But taking the time value of money into consideration is more accurate method of figuring out whether you have made the right decision or not. And then you saw how to find it using ARR, that is a accounting rate of return, which also does not take into account the time value of money. And then you also saw what is internal rate of return. Okay, now I want you all to hear, watch this video and then answer the questions along with this video. After completing, try to solve the problems on the worksheet and test books. See you all in seminar 1.